With the proper techniques and tools, overhauling the Mark III pump is quick and simple. Tools required to properly and easily maintain the Flowserve Durco Mark III pump include hand, socket, Allen, and spanner wrenches, a soft mallet, screwdrivers, bearing pullers, bearing induction heaters or a hydraulic press, and dial indicators. To simplify maintenance, Flowserve also recommends using the specialized tools provided in the Durco Mark III tool kit, which includes an impeller wrench and the Flowserve shaft guide. This kit can be ordered from any Flowserve sales engineer or from a Flowserve distributor. For demonstration purposes, a Mark III Group II pump with the standard Mark IIIA power end will be utilized. To ensure a safe, timely, and proper repair of the pump, it is important that a couple of key factors be considered. Confirm the pump has been drained and decontaminated. Your safety and the safety of others depends on it, so play it smart. If you're not 100% certain the pump has been both drained and decontaminated, do not touch the pump. Instead, notify safety personnel immediately. Determine the cause of pump failure. Knowing the manner of failure will ensure proper corrective action is taken and expedite repair. When equipped with its exclusive reverse vane impeller, the Mark III pump can be overhauled in the shop without the casing, precluding the often difficult task of unbolting the casing from the piping. If the pump arrives in the shop with the casing, however, place a shim under the leading edge of the bearing housing foot before bolting it to the table. This raises the casing end of the pump, making the casing easier to remove. The impeller can be removed using a special Flowserve impeller wrench, which makes the job significantly easier and eliminates the possibility of shaft and keyway damage. Key the wrench to the shaft and place the handle to the right side of the pump as viewed from the motor end. Wearing heavy gloves to protect your hands, grasp the impeller and rotate it until the wrench lifts to the 11 o'clock position. Rapidly twist the impeller in a counterclockwise direction, bringing the wrench down against the bench. The sharp impact of the wrench upon the bench will break the impeller loose from the shaft. Several raps of the wrench may be required to loosen stubborn impellers. Unscrew the impeller from the shaft and remove and discard the impeller gasket. Flowserve recommends that 2 people work together to remove Group III impellers due to their significantly greater weight and the increased chance of thread damage. Note the material code located on the stub of Group II and III impellers and on the rear shroud of Group I impellers. Before removing the rear cover, install a Flowserve shaft guide to protect the shaft. Next, remove the gland nuts and push the gland back toward the bearing housing adapter. Remove the rear cover cap screws and install guide studs to support the weight of the rear cover as it is removed. Doing so will prevent damage to the shaft and mechanical seal. If the rear cover is stuck, a couple of raps with the handle of the impeller wrench will usually break it loose. However, this should not be done on high silicon iron, high chrome iron, and zirconium, as well as non-metallic pumps. They may break. Note the material code found on the back side of the cover. If the pump has a mechanical seal, remove it from the shaft at this time. Finally, remove the seal gland and shaft guide. If the pump is fitted with a removable shaft sleeve, slide it off. If the sleeve is stuck, use a gear puller with its jaws engaged in the gap between the sleeve and the shaft to break the sleeve loose. The Mark IIIA power end boasts numerous reliability and maintenance-enhancing features. Double-row angular contact outboard bearings and single-row deep-groove inboard bearings. External micrometer impeller adjustment. Double-lip oil seals. Top-mounted vent and oil filler. Constant level oiler, and a large diameter reflective sight glass. Carrying a lifetime warranty, the optional ANSI 3A power end also features Impro VBXX non-contact vapor block bearing isolators for improved lubricant quality and temperature throughout the life of the pump. To begin disassembly, Drain the oil from the bearing housing. Loosen the 3 set screws on the bearing carrier and rotate it counterclockwise until the threads disengage from the bearing housing. Withdraw the shaft assembly and place it upright in a stable location. Use heavy-duty snap ring pliers to remove the bearing snap ring. On Group 3 pumps, remove the screws from the bearing retainer ring and separate the bearing carrier from the shaft assembly. To remove the bearing carrier from the shaft, drop the coupling end of the shaft onto a soft surface, such as a block of wood. The impact would cause the bearing carrier to separate from the shaft assembly. Remove and discard the bearing carrier O-rings and the double lip oil seals. If the pump is equipped with bearing isolators, examine them to assess their condition. If the bearing isolator is damaged, remove and discard it. If it is in good working condition, the bearing isolator can be left in place. If the bearing housing adapter O-ring must be replaced, tip the bearing housing onto the adapter and remove the bearing housing cap screws. Pry the 2 components apart. Remove and discard the adapter O-ring. After removing the pipe nipples, plugs, vents, and sight glass, thoroughly clean all grease and scale from the parts and ensure they are reusable. For optimal performance, always replace broken, worn, or corroded components with genuine Flowserve parts. With the proper techniques and tools, overhauling the Mark III pump is quick and simple. Tools required to properly and easily maintain the Flowserve Durco Mark III pump include hand, socket, Allen, and spanner wrenches, a soft mallet, screwdrivers, bearing pullers, bearing induction heaters or a hydraulic press, and dial indicators. To simplify maintenance, Flowserve also recommends using the specialized tools provided in the Durco Mark III toolkit, which includes an impeller wrench and the Flowserve shaft guide. This kit can be ordered from any Flowserve sales engineer or from a Flowserve distributor. To ensure a proper and expeditious repair of the pump, it is important to address 3 critical factors prior to assembly. Verify that all parts needed for the repair are available. Be sure to match the material codes of the replacement parts with those of the original parts. And to ensure optimal pump performance, always use genuine Flowserve parts. Make sure the correct assembly specifications are on hand. Assembly specifications are detailed in the pump's user instructions, which can be downloaded at www.flowserve.com. The literature number is 715-69102. Establish a clean workspace. Maintaining a clean workspace while assembling the pump cannot be overemphasized. The pump will perform better and last longer if assembled with clean parts and in a clean environment. If new bearing isolators are being installed, radius the adapter and bearing carrier bores to remove sharp edges. Lubricate the outer O-ring of each isolator and push them into place. Be sure to orient the inboard isolator so the drain is at the 6 o'clock position. When using double lip oil seals instead of bearing isolators, install the lip seals with their black lips facing the atmospheric side of the bearing housing. After verifying the bearing housing and adapter surfaces are clean and burr-free, install a new adapter O-ring and bolt the components together. If replacing the shaft, match the material code found on the coupling end with that on the replacement shaft. As a precaution while working with the shaft, always use the Flowserve shaft guide. Inboard and outboard bearings have a slight interference fit which requires that they be pressed on the shaft with an arbor or hydraulic press. Never press on the outer races, as this will damage the bearings. Alternatively, heat the bearings to 93 degrees Celsius or 200 degrees Fahrenheit and quickly position the bearings on the shaft. Prior to installing the second bearing, place the snap ring or bearing retainer ring on the shaft. Be certain to position the snap ring with its flat side toward the outboard bearing. After the bearings are installed, tighten the lock nut and bend a tab of the lock washer over the lock nut slot. Fit new O-rings onto the bearing carrier. Slide the outboard bearing into the bearing carrier. Install the outboard bearing retaining device. For Group 1 and 2 pumps, use snap ring pliers to slide the snap ring into the groove in the bearing carrier with its flat side against the outboard bearing. For Group 3 pumps, slide the bearing retainer ring against the outboard bearing and tighten the fasteners in a cross-pattern fashion. For safety and convenience, it is helpful to bolt the pump to the work surface at this point. The bearing carrier O-rings and threads should be lubricated with oil before installing the assembly into the bearing housing. Thread the bearing carrier into the bearing housing by turning it clockwise to engage the threads. Turn the carrier until the carrier flange is approximately 3 mm or 1/8 inch from the bearing housing. Install the pipe plugs, nipples, vents, and the sight glass. If the pump has a replaceable shaft sleeve, coat the inside of the sleeve and the shaft with anti-seize and slide it over the shaft. Secure the sleeve with the Flowserve shaft guide. To maximize reliability of pumps, it is important that certain parameters and dimensions are measured and maintained within specified tolerances. Note that for some of the measurements, it is critical that the rear cover be installed. To measure shaft end play, attach a dial indicator to the bearing carrier and place the tip on the end of the shaft. Observe indicator movement while tapping the shaft from each end in turn with a soft mallet. End play should not exceed 0.05 of a millimeter or 0.02 of an inch. Critical to bearing and seal life, shaft runout is measured by attaching a dial indicator to the bearing frame and placing the indicator tip on the shaft midway between the frame and the shaft end. Rotate the shaft 360 degrees. The maximum allowable full indicator movement is 0.25 of a millimeter or 1/1000 of an inch. Seal chamber face runout occurs when the seal chamber face is not perpendicular to the shaft axis, causing the seal to wobble. To measure this condition, the rear cover should be installed. Attach a dial indicator to the shaft with the indicator tip in contact with the face of the seal chamber and rotate the shaft 360 degrees. The full indicator movement should not exceed 0.08 of a millimeter or 0.03 of an inch. An eccentric seal chamber bore or gland register can interfere with the piloting and centering of the seal components and alter the hydraulic loading of the seal faces. To measure register concentricity, the rear cover should be installed. Attach a dial indicator to the shaft with its tip contacting the seal chamber register, also called the pilot diameter. Rotate the shaft 360 degrees. The full indicator movement should not exceed 0.13 of a millimeter or 0.05 of an inch. From this point on, the assembly procedure will vary according to the type of shaft sealing device used. Procedures for installing single component and single cartridge type mechanical seals will be demonstrated. The rear cover provided by Flowserve can contain one of 5 different sealed chamber configurations with either cylindrical or tapered bores and small, large, or integral glands. This pump has an FML seal chamber which features a tapered bore with flow modifiers and a large gland. Examine the frame adapter counter bore and the rear cover mating surfaces to ensure they are clean. With the guide studs and the Flowserve shaft guide installed, press the rear cover fully into the frame adapter. Remove the guide studs and replace them with cap screws. Remove the shaft guide. Before installing the impeller, ensure both the end of the shaft and the impeller mating surfaces are clean. If a component mechanical seal is being used, the impeller gasket need not be installed at this time, since the impeller will be removed after the clearance is set. If a cartridge seal is being used, it can be installed and the impeller settings made. Installing the seal at this time eliminates the need to remove the impeller later. For proper cartridge seal installation instructions, refer to the mechanical seal installation portion of this video or the user instructions. Apply anti-seize to the threads and screw the impeller onto the shaft. Install the impeller wrench again, this time with the handle to the left side of the pump as viewed from the motor end. Wearing heavy gloves, grasp the impeller with both hands and rotate the impeller until the wrench lifts to the 1 o'clock position. Forcefully twist the impeller in a clockwise direction, bringing the wrench down against the bench 1 or 2 times. Note that impellers made of titanium, zirconium, high silicon iron, and high chrome iron require special installation instructions. Please refer to the installation manual when utilizing impellers of these materials. The running clearance of the reverse vane impeller is set between the impeller and the rear cover. Conversely, the running clearance on the optional open impeller is set between the impeller face and the casing. Running clearances are provided in the user instructions. The running clearance for temperatures cooler than 93 degrees Celsius or 200 degrees Fahrenheit is 46 hundredths of a millimeter or 18 thousandths of an inch. For reverse vane impellers, first loosen the 3 bearing carrier set screws. Rotate the carrier counterclockwise until the impeller lightly touches the rear cover. For convenience, the Mark III bearing carrier has a series of indicator notches cast into the flange. Each notch represents 1/10 of a millimeter or 4 thousandths of an inch of axial shaft movement. Using the notches as a guide, rotate the bearing carrier clockwise the appropriate amount to establish the requisite running clearance. To compensate for thread draw caused by tightening the set screws, rotate the bearing carrier an additional 1/2 notch. Lastly, uniformly tighten the set screws in incremental steps to the published torque values. For example, to set a running clearance of 46 hundredths of a millimeter or 18 thousandths of an inch, turn the carrier 4½ notches and then another half notch to compensate for the thread draw. For open impellers, loosen the bearing carrier set screws and rotate the carrier counterclockwise until the impeller is close to the rear cover. Install a new casing gasket and the casing, fully tightening the casing nuts. Next, turn the bearing carrier clockwise until the impeller lightly touches the casing. As previously noted, each notch on the Mark III bearing carrier represents 1/10 of a millimeter, or 4 thousandths of an inch, of axial shaft movement. Using the notches as a guide, rotate the bearing carrier counterclockwise the appropriate amount to establish the requisite running clearance. This time to compensate for thread draw caused by tightening the set screws, rotate the bearing carrier clockwise 1/2 notch, or 5/100ths of a millimeter, or 2 thousandths of an inch. Lastly, tighten the set screws. If using a component seal, remove the casing from the pump to enable seal setup. It is essential that sealing devices be installed with precision, care, and cleanliness. Always review the seal assembly instructions provided by the manufacturer prior to installation. For demonstration purposes, single component and single cartridge type mechanical seals will be installed. To seal properly, the rotary portion of a single component seal must be installed a specific distance from the face of the seal chamber. This distance is called the seal set dimension and is obtained from the cross-section drawing that comes with the seal. To establish this dimension, first apply bluing to the pump shaft near the seal chamber. Place a metal scale flat against the face of the seal chamber. Push the scale down onto the shaft and turn the shaft to scribe a line. Remove the impeller and rear cover and reinstall the Flowserve shaft guide. From the scribed line, measure the seal set dimension as indicated in the manufacturer's seal assembly drawing and mark the shaft accordingly. To prepare the seal gland for assembly, lubricate the seat bore and the seat O-ring with non-abrasive waterless hand soap. Press the seat fully into the gland. slide the gland and gasket onto the shaft against the frame adapter. Lubricate the secondary seals on the mechanical seal, shaft, and shaft guide as recommended by the manufacturer. Next, slide the seal face first onto the shaft. Position the seal so it is even with the setting line and tighten the set screws. Reinstall the rear cover and impeller, including the impeller gasket. Install the gland to the seal chamber by tightening the gland nuts. As the gland nuts are tightened, the seal will compress approximately 3 mm or 1/8 of an inch. Cartridge seal installation is simple and fast. With the impeller and rear cover removed and the shaft guide in place, lubricate the internal O-ring as recommended by the manufacturer. Slide the seal onto the shaft. Reinstall the rear cover and impeller, including the impeller gasket. Properly orient the gland per the manufacturer's drawing and tighten the gland to the rear cover. Finally, tighten the set screws of the seal to the shaft and remove the assembly clips. Before recommissioning the pump, install a new rear cover gasket and bolt the pump to its casing. Fill the bearing housing to the proper level with the specified lubricant. If bearing isolators have been installed, replace the vent with a plug at this time to prevent contamination. For installation, alignment, and startup procedures, refer to the user instructions provided with the pump. By adhering to the maintenance instructions discussed in this video and provided in the user instructions, the Flowserve Durco Mark III ANSI pump will provide years of service in even the harshest applications. Maintenance-friendly features such as the reverse vane impeller and micrometer impeller adjustment enable plant operators to quickly service pumps and maximize plant uptime.